Right, welcome to Physics Tips for Cambridge students. In this video, we are going to be giving tips on how to answer paper 5 questions. So without much further ado, let's get started. Right, we are going to start off by looking at the first question, that is question number 1. How to answer question number 1. Now, the first tip there is to read the question. Okay, you should read the question carefully and understand it. Okay, very, very important, because if you do not understand the question, the chances of you putting the wrong variables, say you name the other one as an independent variable and it's supposed to be a dependent variable, those chances become very high. So I recommend that you read the question at least twice, then you understand the question, and then you go ahead and start answering the question. Now, the way to answer this question is to imagine yourself doing this practical in the school laboratory. Imagine yourself how you'd perform the experiment in the lab. And the question requires as well that you give detailed explanations of the experimental procedures, e.g. how to control the variables, how to take measurements, and also how to analyze the data. Okay, so I would say that secondly, you need detailed responses. Okay, so this detailed responses needed. Okay, so you need detailed responses of your account. Very, very important. So how to control? Many people confuse the two words, control of variables and constant variable. Okay, so control of variables, that means how you would vary, okay, the variables. And then constant variable is how to keep, okay, how to keep a certain variable constant. So very, very important. So control of variable and constant variable. I've seen on students' accounts where someone writes to control, I'm going to control X, I'm going to control Y. Now, controlling doesn't mean that you're keeping it constant. It means how you are going to vary it throughout the experiment. And then there's always a variable that you're going to keep constant, and that variable you need to tell how to keep it constant. Now, the third thing now is to follow the following, like just say maybe the subheading. Let's just call them subheadings. Okay, so the subheading that you should follow will be in this format. Okay, let's go down. Okay, right, so the first one is define the problem. Okay, now in defining the problem, you are listing the dependent variable, right? So you list the dependent variable. You also list the independent variable. And then you also state the variable that is supposed to be kept constant. Okay, so the variable that's supposed to be kept constant, you need to keep it, you need to state it. Okay, so defining the problem, this is how I recommend my students to do it. They have to answer it in subheading format, defining the problem. Okay, in defining the problem, you are just listing the independent variable, you are listing the dependent variable, as well as the variable that should be kept constant. You are also allowed to just write vary x and obtain y readings, something like that. In other words, the independent variable is the one that you vary, and then to get the dependent variable. Okay, to get the dependent variable. So in a fresh page, so the independent variable and dependent variable. I'm going to give an example. So for instance, you have got k is equal to rc. Okay, let's just say rcx. Okay, right. So suppose you are varying, or maybe let's put it, it's going to be 1 over k c, then you've got we've got x there. Okay, so suppose c and k are constants, so which means in this format here, please ignore this part. So in this format here, this one becomes your dependent variable. Okay, that's the dependent variable, and then x is going to be your independent variable. Okay, so independent variable is what you vary. So you're going to vary x, and then you are going to obtain r readings. And then c is going to be the variable that you keep constant. Okay, whereas this one can be a constant of proportionality. Okay, or something, a constant that will be present in there, but you may be keeping c constant in that experiment. So very, very important to know which variable you're going to vary and which variable you're going to obtain after you vary. So the one that goes on the y-axis is going to be your dependent variable. So your dependent variable goes on the y-axis, and your independent variable will go on the x-axis. So very, very important. Then you have your graph like that. So that is very, very important. Now, moving forward, the third, so remember we said defining the problem. Then we have in defining the problem, we've got listing the dependent and the independent variable, as well as the variable that should be kept constant. Then you have the second subheading, which is going to be the method of data collection. Okay, methods of data collection. So in the methods of data collection, right, we are back again there. In the methods of data collection, we are looking at a diagram. Okay, so you are going to draw a diagram. Right. So in drawing a diagram, make sure that your diagram is not hanging in the air. Okay. So your apparatus must not hang in the air. If you're supposed to use a retort stand, clamp and boss to make sure that you fasten, or you make sure that your equipment, like say you've got a mass spring system, you must include the retort stand. You must also include the boss and the clamp, so that you have, so you just say that's the clamp, and then you have your mass, the spring system oscillating over there. Okay, so that is your retort stand, and it is on a bench. Okay, so like that. So make sure that you label this as your stand. You don't draw the mass spring system in the air, just drawing the spring and then the mass, and then you say this is the, no, this diagram is not allowed. Okay, you are not given any mark on this diagram. Make sure that you have the support that is needed in that experiment is also included. So diagrams must not hang in the air. Okay, diagrams must not hang in the air. You must use the retort stand if you're supposed to, and like that. If it's like going on the table, say you've got a ball that is rolling on the table, you must draw the table as well, and then show the ball as it moves along. And then you must show labels. Okay, very important. So at least 3 labels of not so obvious equipment, must be included. Okay, so in this case, you can have your spring there, you have your mass, you have the stand. Okay, so then you can say now when they say table and so forth, that may not hold water. So spring, very important. And then you can label the support, the mass, the stand, very, very important there. So I think that is that on the table. Yes, on the diagram. So diagram is number one under methods of data collection. Number two, you have a detailed procedure. Okay, so detailed procedure, very, very important. So in the detailed procedure, if at all you are measuring the length, say here you are measuring the length using a meter, then you must say measure L using a meter rule. So it's very, very important to list the apparatus that is being used to measure L. Don't say just measure L. No, measure L using a meter rule, measure small t using a stopwatch, something like that. So the instrument that is going to be used in the measuring process must be mentioned as well. Okay. Remember, in the detailed procedure or in the methods of data collection, here what we are doing here, we are trying to explain how the independent variable is going to be varied to produce the dependent variable. So we are showing how we are going to be varying the independent variable to get our dependent variable. So it is very, very important to state the measuring instrument that we are going to be using in the process. Then if we are to mention light gates, remember in my video on practicals, the paper 3-1, I mentioned that when you are to mention light gates, you've got to also mention that they are connected to a timer. Connected to a timer. So use light gates connected to a timer. Right. It is not sufficient to draw a stopwatch on the diagram there. Some people do that. They draw the stopwatch and then they just leave it like that and then label stopwatch. That is not regarded if you do not mention here that the time is measured using a stopwatch. You need to really state it under the detailed procedure there. We have to say that time is measured, the time taken for 20 oscillations or to complete 20 oscillations is going to be done so using a stopwatch. So it's not important, it is not enough, in effect. It's not enough just to mention the stopwatch or to draw the stopwatch there. It's just on display. It hasn't been mentioned there. It has to be mentioned. Also, if you are to mention the video camera, you also need to state that you're going to take frame by frame. Also, they are connected to a timer, some sort of timer. If the motion is too fast to be recorded by a stopwatch. Okay, so you have to mention these as aids to the measuring process. Now, then under methods of data collection, so I said that you need to mention how the independent variable is going to be varied to obtain the variable, the dependent variable. Very, very important, like I said. Now, I think I'm now on a new page. Hope it will allow me to. Yes. So I think you need to mention that they're connected to a timer, like I said, the light gates. The variable that needs to be kept constant as well, you need to mention it. Variable to be kept constant. You need to mention it. How you are going to do so. Okay. How this is achieved. So how this is achieved needs to be also written down. So again, I'm going to repeat. Control of variables refers to adjustments or varying the variables, not necessarily keeping a variable constant. Right, so I think from there we have exhausted methods of data collection. We now have the next subheading, which is going to be methods of data analysis. Methods of data analysis. Okay, so in the method of data analysis, you have the equation. I think we had one. I wrote there. We said R is equal to C over K times X. That's the one that you're working with. R is equal to C over K times X. So the formula is R is equal to C over K times X. Now, in the methods of data collection, analysis rather, we are now saying that we are going to plot a graph of R versus X. Okay. So we want to linearize the function. I know you know what it means by what I mean by linearizing. We want to plot a straight line graph. Okay. We want to plot a straight line graph. So the straight line graph might be like this, or it could be like that. Okay, passing through the origin or not. So R versus X or R versus X. Want to see which one applies in this case. Now, in this case, we are now using the format y is equal to mx plus c to find the analogy between the two. So r is equal to c over kx. Now, as you can see, there's no y-intercept. So which means you plot a graph of r versus x. So r will be your y, and then x will be your x, like that. So which means c over k would be equal to the gradient. Now, it is not enough again to mention that you just leave it like this and say y is equal to mx plus c, then you circle like this. You need to mention that you plot a graph of r versus x. Okay, mentioning y is equal to mx plus c and not explaining what the significance of y is equal to mx plus c in this question does not score any mark. So please make sure that you mention that r is on the y-axis and x is on the x-axis on there. And then also saying that c over k is equal to the gradient is not enough, because we want to find c. So finding c in the question, you would make c the subject of the formula. It depends what they want. So if they say, how would you find the constant of proportionality, which maybe could be k in there, then you'd say then that c or k or something like that. So in this case, I'm using c. So c is equal to gradient times k. So whatever gradient you get times k, you get c. So you must leave it in like with whatever constant you have as your subject. Okay, so which means c is equal to gradient times k. Very, very important. Now, it is also important to check the examiner's reports for this particular paper. The examiner's reports gives you a concise answer or concise way that you are supposed to answer this question. Okay, so you find some of the things that I'm mentioning that they are there in the examiner's reports. So like I said, that it is not important, it is not enough to just mention that y is equal to mx plus c. You need to state, okay, you need to state. So I mentioned that. So please, you need to state the relationship between y is equal to mx plus c and that. So in this case, you can see that there is no y-intercept in this particular relationship. There is no y-intercept. So which means our graph passes through the origin. So the second statement you need to say then under this. So remember I said the first statement is plot a graph of r versus x. Okay. Then you say if the relationship is true. You really have to write this. It's very important. If the relationship is true, then a straight line graph is obtained. Okay, straight line graph is obtained which passes through the origin. Okay, through the origin. So this one you really need to write it down. The straight line graph is obtained which passes through the origin. A straight line graph is obtained which passes through. Some also may say the relationship is valid if a straight line graph is obtained which passes through the origin. This is after when you have seen that there is no y-intercept. If there is a y-intercept, then everything changes. You say if the relationship is true, a straight line graph is obtained whose intercept is going to be equal to, okay, or which does not pass through the origin, or whose intercept, y-intercept, is equal to, then you state whatever it's going to be equal to according to the analogy between y is equal to mx plus c and the function that you're working with. Please let me know in the comments section if you have any questions surrounding this method of data analysis. So I said there are two statements there. The first statement is a graph of r is equal to r versus x is plotted, and then if the relationship is valid, then a straight line graph is obtained which passes through the origin. Then after this we have additional detail. Okay, additional detail. In the additional detail, the first thing that you need to mention there should be of regarding safety. Okay, so the safety first. Okay, now the tips that I can give you on safety, if there are falling objects, right? Say you've got that mass spring system and the spring sometimes you know the masses can fall down, then you need to put a cushion. Okay, you need to put a cushion on the floor. Okay, so that you don't damage the floors and you don't maybe break whatever is falling. So cushion is for falling objects. You need to give a reason for the safety detail that you are giving. Okay, so the safety precaution must be accompanied with a reason for it. Now, if there is noise being produced in the circuit, you need ear protection. So earmuffs. Okay, so ear protection for noise produced, and then you also have eye protection for so eye protection should be granted. That is, if you have something that may be like flying objects. Okay, small flying objects, you need to wear goggles to protect your eyes. Then after that, you now have the additional detail. So some of the marks that you find that some of the marks that are there in the methods of data collection are given in the additional detail. Okay, so some of those marks are given in the additional detail. For instance, during the course of the experiment, you may want to talk about say maybe the formula T is equal to 1 over F. Okay, say you are using a stopwatch and then at the end you're supposed to talk about frequency. Then the period that you have is equal to 1 over F. So that formula will be awarded as an additional detail mark. Okay, that formula will be awarded as an additional detail mark. So you find that you have got formulae that may be present that may allow you like to calculate other functions, and then also the issue of having repeat readings or repeating the procedure so that you decrease random error. So all that is also awarded under additional detail. So repeat readings, very, very important. Also, the use of maybe, let's say you want to use the CRO, the detailed use of a CRO. Suppose you have mentioned you can find the frequency from this cathode ray oscilloscope. Okay, so the detailed use of how to use the time base of a CRO, if you mention it under additional detail, they will give you the mark. Okay, so the additional, remember the time base setting is the one that gives you the time. Then from the time you get the frequency. Okay, so you need to mention the setting, time base setting. Remember, it's always like seconds per division, and then multiplied by the number of divisions that give you a period, like on the waveform. Then you have the period, the time taken to complete a period, and then you say 1 over f to find 1 over t rather, to find the frequency. So all that is under additional detail. Right, so I think I've exhausted the question number 1. That is the design question. So again, just to recap, defining the problem. Then after defining the problem, you have methods of data collection. After methods of data collection, you've got method of analysis. After method of analysis, you do have the additional detail. Remember, I said there's always 1 mark that is awarded for the safety under this, and then you have others where you need to state formulae that you may have applied in the methods of data collection, as well as mentioning that you're going to repeat readings and find average and so forth. And then detailed use of some equipment. Suppose it could be a hole probe. Okay, how to use a hole probe, that you need to calibrate it first. Then after calibrating it, place it in the magnetic field and so forth. So that alone shows you that you're somebody that understands these equipment found in the lab. Now, before I close or stop this video, this particular question requires you to have done some practicals. So it's easy for you to imagine the practicals if you have done them. So it's very, very important for you to do the practicals and also to pay attention mostly when you do those AS practicals, such that when this takes place, when you're given a question in paper 5, you know exactly how to maneuver. Right, so I think if you like this video, give it a thumbs up. Please like, share, comment, as well as subscribe to the Physics Tips for Cambridge Students YouTube channel.